You ever get stuck on one of those quadratic equations that just refuses to factor? It can be pretty frustrating. Well, today we're going to unlock a really powerful algebraic technique that solves those seemingly impossible problems. It's called completing the square, and you're about to see how it turns a total mess of an equation into a simple, elegant solution.
All right, let's just dive right in with a challenge. How would you solve for x in this thing? Your first move is probably to get everything on one side, right? So you get x squared plus 4x minus 24 equals 0. And the first instinct for all of us is to try and factor it. But go ahead and try. Find two numbers that multiply to negative 24 and add up to 4. Yeah, you're not going to find them. It's a dead end. So what do we do when our go-to method fails? We find a new one.
And that's exactly what we're talking about here, the factoring dead end. It's a super common roadblock in algebra where the tools we know and love just aren't quite enough for the job.
Look, the reality is a ton of quadratic equations aren't designed to be factored neatly. It's not you, it's the equation. It just means our algebraic toolkit needs an upgrade. So today, we are adding a serious power tool to that box, completing the square.
So what exactly is this new tool? Well, the core idea is actually kind of beautiful. Instead of trying to find a solution that's already there, we're going to build one. We're going to construct something called a perfect square.
So this is what we're aiming for, a perfect square trinomial. It's a special kind of three-term expression. Just look at the pattern here. The last number, 49, is just 7 squared. And the middle guy, 14, is just double that 7. This perfect little structure lets it collapse neatly into x plus 7 squared. And that right there is the whole key, because once you have something squared, all you have to do is take the square root to solve it.
Okay, check this out. On the left, x squared minus 10x plus 25. That's a perfect square. Why? Because that last term, 25, is exactly the square of half the middle number. See? Half of negative 10 is negative 5. And negative 5 squared is 25. That's the pattern. And it lets you factor it down to x minus 5 squared. Now look at the right. Just by changing that number to 20, the whole pattern is broken. It's not perfect anymore. Our mission is to find that one perfect number every single time.
So how in the world do we find this perfect number? Well, it's not actually magic, even though it kind of feels like it. It's a simple, super reliable three-step method. Let's just walk right through it. Here is the recipe. Step 1. Get your x squared and x terms all by themselves on one side of the equation. Step 2. This is the secret sauce. You take the coefficient of the x term, we call that b, you divide it by 2, and then you square it. That gives you the magic number. And then step 3, you just add that magic number to both sides of the equation. You got to keep it balanced, right? And that's it.
Okay, theory is great, but let's see this thing work. We're going to take this three-step method and use it on a problem that looked totally unsolvable just a few minutes ago.
Okay, let's solve x squared minus 6x equals negative 4. Now notice that step 1 is already done for us. The x terms are already isolated on the left, so we can jump straight to the fun part. Time for step 2. Let's find that magic number. Our b value here is negative 6, so we divide that by 2, we get negative 3. Then we square it, and negative 3 times negative 3 gives us a positive 9. There it is! 9 is the number that's going to complete our square. And now for step 3. To keep everything fair and balanced, we add 9 to both sides. And would you look at that? The left side now says x squared minus 6x plus 9. We have officially built a perfect square trinomial. And here is the payoff. That trinomial we just created collapses perfectly into x minus 3 squared. And the right side, negative 4 plus 9, that's just 5. I mean, look at that! We took a messy problem and turned it into something so clean and simple. From here on out, it's smooth sailing. We just take the square root of both sides. And please, please don't forget the crucial plus or minus on the right side. That gives us x minus 3 equals plus or minus square root 5. Then we just add 3 to both sides, and we have our two solutions. Problem solved. Okay, so that's the basic rundown. But, problems in the real world aren't always set up so nicely for us. So let's look at a couple of common variations you're definitely going to run into.
Here is a classic curveball. What if there's a coefficient, a number, sitting in front of the x squared term, like this 2? Does this break our whole method? Not at all. We just need to add one little preliminary step to our process.
The rule is simple, and it's non-negotiable.
To complete the square, the coefficient of x squared absolutely must be 1. So our first move is always to divide every single term in the equation by that leading number. In this case, we just divide everything by 2.
And check out what happens when we do that. Our complicated-looking equation just simplifies down to x squared minus 10x equals 4. And all of a sudden, hey, that's a familiar problem. We already know exactly how to solve that. From here, the steps are identical.
So you can think of this as your strategic checklist. If the equation is already set up nicely, you can just start the 3-step method right away. If there's a number out front, your first move is always to divide. And if there's a stray constant term on the left side with the x's, just move it over to the right. It's all about prepping the equation to make it easy to solve. So let's just boil this all down. Completing the square is all about building a perfect square trinomial when you don't have one. The absolute key is finding that magic number, b over 2 squared, and adding it to both sides. And remember, you always have to make sure the x squared term has a coefficient of 1 before you even start. This is your secret weapon for all those times when factoring just doesn't cut it.
And that's really all there is to it. But here's a final thought that's pretty cool. This method isn't just some random algebra trick. This process is the exact same one that's used to derive the famous quadratic formula. What you learned today is the fundamental logic, the engine behind one of algebra's most powerful equations. It really makes you wonder, doesn't it? What other impossible problems are out there that are just one new technique away from being solved?